Now we want to figure out what the vapor pressure of our solution is going to be. So the mole fraction of the water is 0.974. The vapor pressure of the pure water at that temperature is 102.1. So that's going to give us a new vapor pressure of 99.4 torr. And again, we know that by adding a solute to a solvent, we lower the vapor pressure, and it went from 102.1 to 99.4. Now let's do a molar mass calculation. At 29.6 degrees Celsius, water has a vapor pressure of 31.1 torr. A solution is prepared by adding 86.7 grams of substance Y. We don't know what it is, but we're told it's non-volatile, which means it's not going to contribute to the vapor pressure, and it's a non-electrolyte, so it's not going to break up into ions, to 350.0 grams of water. The vapor pressure of the solution is 28.6 torr, and that's what we have been solving for before, but now this time it gives it to us. We want to know what the molar mass for Y is, and we know that molar mass is grams per mole. We can calculate the moles, and then we can figure out the molar mass. Okay, so we're dealing with vapor pressures again. So the vapor pressure of our solution will equal the mole fraction. The vapor pressure of the solution equals the mole fraction of the water times the vapor pressure for the pure water. This time we're given the vapor pressure of the solution. It tells us it's 28.6 torr. We want to calculate what the mole fraction is. And it tells us that the vapor pressure for pure water is 31.1 torr. Now, we're told that we've got 350 grams of water. So 1 mole of water is 18.02 grams of water, which gives us 19.4 moles of water. So now we can plug that in here. We've got 28.6 torr equals 19.4 over 19.4 plus x, where x is the mole fraction of or the moles of our solute, and we'll multiply it by 31.1 torr. So we're going to need to multiply or divide both sides by 31.1, and that's going to give us 0.920 equals 19.4 over 19.4 plus x. We'll multiply both sides by 19.4 plus x, so that'll give us 17.848 plus 0.920x equals 19.4. We're going to subtract 17.848 from both sides, and that'll give us 0.920x equals 1.552. Dividing both sides by 0.920 is going to give us 1.69, and that's how many moles of solute we have. So our molar mass is grams per mole. It tells us we've got 86.7 grams of solute. We calculated that that's equal to 1.69 moles, which will give us a molar mass of 51.3 grams per mole. But what if the solute is also volatile or can contribute to the vapor pressure? It will contribute to the vapor pressure of the system as well as the solvent will. So our total vapor pressure for our system is going to equal the mole fraction of A times the vapor pressure of A plus the mole fraction of B times the vapor pressure for B. So P total is our total vapor pressure. Our mole fractions of A and B are vapor pressure for pure A and B. So let's look at a problem again. The vapor pressure for pure hexane, and it gives us the formula for that, at 60 degrees Celsius is 573 torr. That of pure benzene, and it gives us the formula, at 60 degrees Celsius is 391 torr. What is the expected vapor pressure of the solution prepared by mixing 58.9 grams of hexane and 44.0 grams of benzene? And it tells us that it's an ideal solution. That basically means that the solute interactions are very similar to the solvent interactions. All right, so we've got our equation. The total vapor pressure will equal the mole fraction of our hexane times the vapor pressure of the pure hexane plus the vapor pressure of our benzene times the vapor pressure of our pure benzene. So we're going to have to figure out what the mole fraction of our two components are first before we can do our problem, which means we have to convert grams to moles. So we've got 58.9 grams of C6H14. 1 mole is 86.2 grams. So that's going to give us 0.673 moles of hexane. We're going to take the 44.0 grams of benzene and convert that to moles. So 1 mole is 78.12 grams. And that'll give us 0.563 moles. Now we can figure out our mole fraction. So our mole fraction for our hexane is going to be 0.673 divided by 0.673 plus 0.563. And that'll give us a mole fraction of 0.544. We're going to figure out our mole fraction for our benzene. And that's going to be 0.563 divided by 0.563 plus 0.673. And that's going to give us 0.456 for the mole fraction for benzene. And notice that when we add the mole fraction of hexane to the mole fraction of benzene, it comes out to be 1.00, and that makes sense because those are the two components in our solution. Now we can figure out what our vapor pressure will be for our total solution. We're going to take 0.544, multiply it by 573, and we're going to add to it 0.456 times 391 torr, and that'll give us a total of 490 torr for the vapor pressure of our solution.